So I'm going to continue where we left off from the last video, where we wrote this single line of code to turn on the LED on the kit. Now what I'd like to do is I'd like to toggle this LED at a specific time and frequency. So let's figure out how we can do this. So firstly, to figure out how to toggle the LED, open the datasheet, go to I/O ports, and in this section just search for toggle. And note that this is actually really at the start of that section on the first page. And you can see that writing a 1 to the pin X register will result in a toggle of the corresponding bit of the data register. Okay, pin X register, that's all we're going to take away from that. So, coming into MPLAB X, we're going to show off something called I/O view. So that's under actions here, and here is my I/O view. Now if I look for port C, I can see current setup. What I need to do is, in order to update live the status of things, I'm going to just debug. And the program's running. I can reset, run, pause, and you can see we're sitting in the while loop. Now looking at I/O view, now I can see that I should be able to just toggle the LED by writing a 1 to the pin C register. And you can see that as I write a 1 there, it toggles, nothing happens as it goes to 0, write a 1 again. So you can see that this functionality is validated. So actually I can write my code now. So pin register, pin C of port C, 1, pin C, 7. So I can quickly set a breakpoint on that line. I need to first restart debugging. And there we hit the breakpoint, and as I step over that, my LED toggles. Okay, so we verified that functionality. Now what I'd like to do is be able to toggle the LED at a certain frequency. So the way I can do this is through AVR Libc. So if I just type AVR Libc, the first link which comes up, and AVR Libc is a free software project, high quality C library on AVR microcontrollers. So going to the user manual, I'm going to go to the library reference, search for delay, and you can see there's a utility delay function. And there's a couple of things that I need to take away from this. Firstly, that there's a define which is required for the CPU frequency. There's a couple of functions, delay milliseconds, and you can see how it is implemented, that this CPU frequency define is before the include function. That's something to pay note of. So, okay, include util delay. So, stop debugging, hash include util delay. Okay, and then I need it in a define of if CPU, and I need to know what is the frequency of the processor. Now in the datasheet I can go to system and clock options, and I can search default, and default clock source device is shipped with RC oscillator 8 MHz with the clock divided by 8 program. So we should expect a 1 MHz system clock. That was actually the example in AVR Libc, so where it said 1 MHz. So we can just copy that define, put it back here, and the function that we had was delay milliseconds. So underscore delay milliseconds, and we can say 1000 for instance. Okay, let's debug, and let's take away this breakpoint, and let's debug. And now you can see that the LED is toggling, but it's toggling a lot faster than what we're really expecting. And so again, let's use I/O view now, and going to I/O view, we're going to continue, and then we're going to pause. And now what we're going to look at is the Under CPU, we can see the clock prescaler here, and the prescaler enabled bit should be set, and we can see that it's not. So our clock speed is actually 8 megahertz instead of 1. Now, I can't actually change this here because it's a special type of register. I'll explain that perhaps in a later video. But I can just go back to my code and in main change my clock frequency to 8, what it actually is as per the registers, and now debugging. We get the frequency that we expected.